and masses of them, lots and lots of them, to beat down the noise in the signal at the South Pole. But they only had one frequency, and with only one frequency, it's hard to know, to be sure that the signal you're seeing is really from the edge of the universe. It's not the galaxy, it's not the Milky Way dust. They've done their best. They've looked at an area with low, the cleanest, or the lowest level of dust emission. But it's controversial as to whether they've really seen a primordial signal. And just in September this year, the Planck satellite team did an updated analysis of dust, and they have some sensitivity to polarization. It's not quite as good as the BICEP signal, but they have it across the whole sky, and they have it in all 9 frequencies. And when they looked at the dust, the galactic signal in terms of polarization, they found that the BICEP, this region here that BICEP had looked at, was not particularly clean. They found a galactic signal, the Milky Way signal, comparable to the BICEP 2 signal. So we now know that BICEP 2 probably underestimated the dust signal in their analysis. We don't know whether it really is a signal of primordial gravitational waves. That's got to be reassessed in the light of the latest Planck data, and that's going to be the further data release from Planck is coming out. It was supposed to be actually it was supposed to be October this year. It got put back to December this year. It now looks like it'll be January next year. We'll get the latest data from Planck, and either then or shortly afterwards they'll do a joint analysis between the Planck satellite and the BICEP data. So we don't know really whether there is a signal of gravitational waves in the scene yet in the micro background sky. There are more experiments coming up. Indeed, BICEP have a further experiment at a different frequency coming up. So inflation not proved yet, I think, is the bottom line here. So I really should wind up. I hope I've told you a bit about some of the research that goes on in cosmology these days. There is very solid evidence for the standard hot Big Bang model in cosmology. A consistent picture emerges from studies of the cosmic microwave background sky from the large-scale structure and galaxy surveys. What we're now trying to understand is where it comes from. And inflation, cosmic inflation at very high energies is the best theoretical model we currently have of where structure comes from. Indeed, where the universe, the matter and energy itself in the universe comes from. It would come just from vacuum energy in the very early universe. Primordial ripples emerge from quantum fluctuations in that picture, and if you extrapolate further, that could give us a multiverse, a vast multiverse beyond the sky, beyond the universe that we see. And what we're doing now is testing these models of high energy physics with astronomical observations. But there's no smoking gun yet for inflation. All the excitement back in March has rather dissipated with the latest Planck data. It seems that BICEP were maybe unlucky in that the signal from the galaxy was larger than they expected. Maybe they overstated their case by going with a major press release when they had a limited amount of information. But that's science to some extent. It remains a work in progress, and this is hope I've given you some flavour of some of the questions that are being studied in cosmology today. So I'll finish there. Thank you.